Hey everyone, welcome to our second lesson in week 5, where today we're going to determine the number of compounding periods, principal and interest in compound interest problems. So last lesson we were looking at just finding the total amount. This lesson we're going to be looking at finding other factors. But first, just one more thing to consider with our compound interest, and that's when we want to find out what's the total interest, capital I, paid out. Well, if we want to figure out how much interest is paid out at the end of the investment, it's simply a matter of finding the difference between the final amount that you have minusing how much you invested. So we've got to do an example using this formula, which you should have also recalled from year 9 down here in example 1. Example 2 and 3, we're going to be using our compound interest formula like last lesson, but we're going to be looking for R and looking for N. So we're going to have to use some logarithms later in the lesson. But for now, let's have a look at example 1. Determine the amount of interest accrued on $5,000 invested for 3 years at 8% per annum. Well, the first thing we want to do is actually figure out what the total amount is. So let's work that out by applying our compound interest formula. Our principal amount is $5,000. We're compounding annually. Now, if it doesn't tell you how often it compounds, you assume that it's annually. 8 on 100 to the power of 3, which means the total amount of the investment is $6,298.56. If I now want to find the total amount of interest that I accrued on that, it's just going to be the difference of the total $298.56 and subtracting what I initially invested. So in other words, the interest accrued on this during this time is $1,298.56. Let's have a look at example 2. Now in example 2, we have $2,000 grows to $3,000, so we have a principal and we already know our final amount. After 6 years, compounding quarterly, so that's 4 times per year. Determine the interest rate it was originally invested at. Well, this time it's a little bit different. Our compound interest formula looks like this, but instead of R on 100, what's different this time is that it's divided by 4 because I'm actually compounding quarterly to the power of N. So I am going to be rearranging for R in this situation, but I need to make sure I remember to divide that R by 4. So the total amount is 3,000. The principal was 2,000. 1 plus R on 400 to the power of 6 times 4. Remember, it's 4 times per year for 6 years, so that's why I'm multiplying those numbers there. Dividing both sides by 2,000. Okay, I end up with, I'm going to come over here now. I end up with 3 on 2 is equal to 1 plus R on 400 to the power of 24. And here's where it gets fun. I need to get rid of this to the power of 24. And we can do that by taking the 24th root of each side. Now, if you don't know how to take the 24th root, or if your calculator is not able to do that for you, just remember, if we want to take, the 24th root of x, that's the same as x to the power of 1 on 24. So that's one of our little surd conversions to fractional indices. So if I want to find the 24th root of 3 on 2, if I don't know how to do that on my calculator or my calculator can't do it, I just want to take that to the power of 1/24. Okay, so that's how we can get around that problem if we can't shortcut it. So doing that, we end up with, on the left-hand side, 1.0170 is equal to 1 plus R on 400 after we take the 24th root of 3 halves. Taking 1 from both sides, and then multiplying both sides by 100, I end up with R equal to 6.82%. So that's my final answer, where the key point is here. Okay, so guys, we don't want to divide by 24. We need to utilize our surd and fractional indices for this step here. And now hopefully you see why it's linking into our index and surd unit. The final question that you could be asked, so we know how to calculate A. If you were given an unknown P, that's pretty easy as well, guys, because you would know all of this and you would go A divided by whatever that number is. But probably the most difficult thing to do is to figure out how long it will take an investment. So here we have an example. How long will it take for a $1,500 investment to grow to $5,000 if invested at a rate of 2.5% compounding monthly? So guys, in this example, I have deliberately chosen 2.5%. That's approximately the interest rate at the moment on investments, and compounding monthly because that's typically what happens here in Australia at our banks. We have a compounding monthly interest on investments. So in this case, we're looking for N, how long it will take or how many compounding periods it will take. So let's get to it. I'm going to start off with our formula. And it's always important to write the formula, as you know. We know our final investment amount is $5,000. Our principal is $1,500. 1 plus 2.5 over 100 times 12. Don't forget we want to divide by that 12, okay, because we are compounding monthly, to the power of N. So let's simplify this. We end up with, if we divide both sides by 1,500, and this is where fractions are your friend, guys, because if you actually do that, you end up with 3.3 reoccurring is equal to 1.0021 to the power of N. So in these cases here, I've actually rounded to decimals, but where possible, keep them as a full fraction or a full number. Now, guys, we're in this predicament where we are looking for the value of the exponent. And the good thing about that is we know how to do that because we know how to use our logarithms. So we know that if we want to find N, and I'm going to go over here for a little bit more space, N will be equal to log of 3.3 reoccurring to base 10 over log of 1.0021 to base 10. And if I pop that in my calculator, I end up with the number of compounding periods as 578.51. But I'm not asking for the number of compounding periods, I'm asking for how long. Now, if I know that there are 12 compounding periods per year, that means that the time it takes will be that many compounding periods. Accidentally popped a decimal in there. 578.51 divided by 12 months to a year. So 578.51 compounding periods is 578.51 months because we compound monthly. So I want to get that in years because I don't really know how many years 578 months is. That gives us 48.21 years. And I tell you what, if you were trying to invest $1,500 and you were going to wait for it to be $5,000, that is a long time to wait at today's interest rates. But I hope that you can see here that once we get to this step, we need to use what we learnt last week with our logarithms to solve this. Now, this kind of practice problems aren't in your textbook, so I popped a worksheet on eLearn for you, and I want you to just have a go at these 4 questions. They do have sub-questions. Don't feel like you need to do them all, but do enough so you are comfortable with finding the unknown values. If you have any questions, make sure you let me know. Thanks, guys.